It's about fabric management and multi-cloud. And again, let's go back where we started. First, let me introduce quickly myself. Jacopo Pianigiani, part of Contrail product management, together with Aniket. Been in this industry for a while, back in Europe. It's about 25 years. I've been in this industry as a SDN and FV architect in the early days of SDN, and then moved over to the Bay Area in the last 2-3 years as a product management. So I'm leading the multi-cloud and fabric capabilities. And it's kind of a natural evolution of Contrail. If you think the vision that Aniket introduced, okay? Why was Contrail disruptive in the industry at the early days of SDN? We're talking about 2012. It's because it was a principle of networking as a service, abstracted through a single pane of glass in a virtualized and physical environment. Now, some of the challenges which I think both enterprise and service provider have seen with the evolution of clouds, whether it's the private cloud data center, where I've got physical infrastructure, virtualized workloads with different hypervisors, then the rise and growth of public clouds, AWS, GCP, which is compute, networking, and storage environment. Yes, unfortunately self-contained to that environment. It's like the private cloud. So to a certain extent, some of the problems that we have seen in the industry is that everybody is taking care about the standard ETSI definition of virtualization and networking, which is compute, networking, and storage. I've got this pod here, and I virtualize these 3 layers here. And I've got this pod here, and I virtualize these 3 layers here. And I got this pod here, and I've got the same 3 layers there. And they don't work together. That's why the principle that we are applying when we say Contrail networking as a service. So networking as a service in the multi-cloud is not about one domain. Yes, it's definitely about also one domain, but how does that domain from a networking perspective to connect apps to apps works to provide the networking as a service across those environments? That is what Contrail networking multi-cloud is about, taking the networking as a service to the next level. And obviously, it has implication in the private cloud, where you have data center with devices, with bare metals, with virtualized workloads. So there is some level of normalization in the foundation that you need to take, which means networking in the specific cloud environments has to be simpler and normalized in order to take a holistic view of networking as a service end-to-end across cloud environments. Now, let's get to the principle. Perfect, thank you. So these are the problems we see there. If I take cloud environments, where I take it from a private cloud, so a private DC, where I have got network operations or DC operations, and I got a few cloud operations people which manage the public cloud in an enterprise and a service provider, well, they're typically very much disconnected altogether. There's nothing in common from an operations, from a setup, sometimes even from a billing perspective, they're not consistent. They are not the same from a visibility. You've got a lot of visibility of how this stuff works. I've seen a lot of companies, whether in the SP, but even much more in the enterprise side, where they started using the public cloud without a clear understanding of what the cost behind it is, which is going to be a kind of an issue moving forward. Because it's very easy to put stuff over the public cloud. It's very difficult to pull it back. Second problem is, okay, I've got these disconnected environments with barriers, from a skill set or even from a tool set perspective. And if I drill down inside one of those bubbles and I got my own data center operations, sometimes I don't even have the same skill set and visibility between the left and the right. But still, if I take enterprise customers, I would say that bare metals, 7 years, 10 years ago, we thought bare metals would disappear like that because that's the era of KVM, and that's the era of hypervisor, that's the era of virtual machine and containers. There's still a lot of them. There's still going to be a lot of them. So the coexistence between those environments, even in the private cloud, is going to be for a long way to go. And this to be a single pane of glass where I have that inside, in this bubble, across those bubbles. Last but not least, the side effect of this fragmentation is that everybody develops based on what he knows. So if I know Ansible, I'll develop my playbook in Ansible. If I'm used to Puppet, I'll use Puppet. If I had whatever else, a management tool from a data center coming from a vendor, I'll use that. That brings an alignment of operations which is bottom-up driven. It's not holistically driven from what I need to achieve. So I need to kind of get to a way in which I normalize. So the perspective that we are taking is more a different view of the cloud. Those clouds are compute, networking, storage environment contained, either owned, like the private cloud data center, where I've got switches, so leaf and spines and gateways, where I attach bare metals, and computes where I may run with vRouter, so a software replacement of the vSwitch with advanced capabilities, where I attach containers and virtual machines. Ultimately, they are still part of my private cloud, right? It's a different way to see vRouter. It's a very capable virtual TOR of my private cloud data center. It's a software virtual TOR to which you attach workloads. And your workloads are virtual machines or containers. If you have a bare metal server, what do? You attach Ethernet ports to one or two leaves. So to some extent, instead of in the bare metal, there's nothing that spins up a bare metal other than the person which plugs the cables. In the virtualized environment, it's either OpenStack or Kubernetes or OpenShift, all the different implementations to spin up the workload, attaching to a virtual TOR, which is in this case is vRouter. So in the private cloud environment, I have a compute, networking, and storage infrastructure that I need to manage. In the public cloud, I have the same. Somebody else is managing the infrastructure on my behalf. So I don't have to image or configure a switch, right? I'm spinning up a VPC in AWS or in Azure. I've got a compute networking where I define my virtual networks, my security groups, my policy or ACLs. Depending on the clouds, they're called differently. But strictly speaking, they are not so different. It's just the semantic of the API you call is kind of slightly different. They copy-paste each other a lot, mostly copy AWS and paste somewhere else. That's mostly the directions we see in the industry. But the language you talk, it's a set of, okay, how do we call it? CloudFormation? No, that's biased. Tosca? Yeah. Tosca REST APIs, which has got a data model for the constructs that you want to provision and configure. How do you manage reachability? Well, still routing. You've got either an overlay with IPsec terminating on a well-defined IPsec gateway that you can spin up, or you've got a direct connect, which, guess what? It's a VLAN to VLAN forwarding model. And how do you make those prefixes available to somebody else? Well, whether you like it or not, it's still BGP. You have BGP sessions inside here going to somewhere else, so it's still a routing problem. And the same happens even in legacy environment, where you got ESXi, right? Okay, yes, I whole stack. vSphere. No, vRealize. I do the whole management of the networking workloads. It's still a pod where I've got my networking layer abstracted. Nobody has ever taken care so far about abstracting that view holistically beyond the boundaries of one of those environments. And that's exactly what we're trying to achieve with Contrail Multicloud, which is taking the abstract view of networking as a service. So I've got virtual networks in a project or in a tenant, to which I attach workloads, okay? And I use my lifecycle management system. Contrail doesn't take care about lifecycle of the workloads. It abstracts networking as a service end-to-end holistically. And then, talking the language specific to those cloud environments or to the fabric that connects those cloud environments, implements those principles in the relevant execution environment, talking the native language of it. So it talks the native public cloud APIs to configure, so as a configuration protocol for the public cloud. To the data center devices, it talks netconfig PCs to this leaf, to the spines, to the gateways, when you have bare metal workloads attached. And it talks the equivalent of netconfig PCs, which is carried over XMPP to the vRouter. So the protocol that the controller uses to the vRouter has got two levels of information: configuration and route leaking. It's carried over, so the controller talks to the vRouter via XMPP, and what it carries is the equivalence of netconfig PCs for configuration and of BGP for route leaking. In the case of physical devices, it really uses netconfig PCs and really uses BGP to advertise routes to make the overlays happening. So the basic principle is that with Contrail networking, I onboard the enforcement point of this heterogeneous environment. And what are the enforcement points? It used to be vRouter. Now it becomes the leaf, the spine, the gateway, because I have to configure and route leak routes to attach workloads to those devices. And what are the enforcement points in the public cloud? The public cloud tenant itself. It's a compute networking and storage pod where my configuration protocol is via API. My forwarding plane is typically a VLAN to VLAN connect with an IGP, typically BGP, to carry over privacy information across boundaries. So the key principle is that I'm onboarding the fabrics. In some cases, I manage the full life cycle of the devices. In some cases, I have nothing to do. And I just build and connect that pod to the rest of the other pods by operating configuration actions inside the fabric itself and interconnecting the fabrics together. So the capabilities that are bringing up from day zero those pieces of infrastructure so that I can build my abstract logical networking between applications and connect them through a single view. And I can collect analytics from those elements talking the native language. So analytics collecting as flow or JFlow from the devices themselves for bare metals. Analytics collected from Sandesh protocol via on the vRouter for the containers and virtual machines directly attached to here. And analytics through the native CloudFormation APIs, not very much reach. So there's different levels of analytics you can get from a public cloud. The native APIs or advanced analytics APIs like the CloudWatch, or if that is not enough, then using a local agent, which means deploying the public cloud with software components to collect analytics and feed analytics information. Let me stop for questions for a moment.
I'm just going to ask one real quick. Do you guys have Terraform providers for this? Is there a use case? I mean, I see a use case for it to be able to stitch everything together.
I mean, it's part of the vision and of the implementations to use Terraform as a way to.
Yeah, because I mean, obviously Terraform supports all of the other components.
Exactly.
But it would be much easier to just say, hey, I'm going to tap into.
It's kind of the higher level view. How do you spin up the whole automation framework for build this automation together? So for instance, we plan to use Terraform to build the capabilities in a heterogeneous environment.
Right.
So there's different levels. You can see it as the way to spin up a cluster in a heterogeneous environment. Right. And then as tier 2 of Terraform, for instance, in the physical data center, in the private cloud, we typically use Ansible to configure the devices. So Terraform is the higher level orchestration that then execute playbooks to execute the specific tasks. In the public cloud, for instance, Ansible doesn't make a lot of sense. No. So we'd rather use Terraform and then go Ansible at the data center level itself.
Okay. But that's coming, is what you're saying. Okay.
So what we're talking about is implant for first half 2018. So the first release is going to be around April. The second release is going to be about June. So we're talking about something which is not available today in Contrail networking. But as Aniket said, it's a core capability of Contrail networking. It's not going to be separate from that. So when we say networking as a service, it's just bringing the networking abstraction as a service across the boundaries of a cloud. That is what multi-cloud is about. So if you move to the next level of detail, and again, I know this has been pretty high level so far. Let's just go ahead, I tried to sum up the kind of use cases, okay? But it's kind of simple. Contrail, what is the mission of Contrail? Is networking as a service. And it's networking and security, as Aniket pointed out. Again, security not just top-down like it used to be from a perimeter firewall perspective. Security is seen from, I need to connect apps to apps, and it's a networking problem brought to the next level, which is applying security policies in that abstract semantic perspective. So what I want to build is a logical connectivity between application tiers, be able to define security policy the abstract semantic way without, as we used to be. When I used to run OpenStack, you have security groups which contain IP addresses. That's really ugly, right? Has nothing to do with, okay, multi-cloud. What is the address of a workload which exists in the multi-cloud? There's no reasons to apply IP addresses. Or you need to have a higher level view. So the principle of policy is really bringing the abstraction of networking to a level where you don't have to carve out the details in the UI, in the actions you do in defining the connectivity between workloads for that specific instantiation of a workload. That workload may exist as a bare metal or as a container or as a virtual machine, and that container may be an EC2 instance. So the principle of your red virtual network of a certain project, you don't have to care about what IP address it gets allocated, or what is the IP address you allocate to the virtual network existing in the VPC or in the Azure public cloud. And obviously bringing that down to the networking level. So the principle is really the fabric connectivity in the middle, whether it's direct connect or IPsec overlays, the private cloud data center, where I have physical workloads directly connected to the data center devices that becomes part of my managed infrastructure. So we start to see a new principle of the cloud itself, where I've got enforcement point becoming the public cloud tenant, enforcement point becoming my DC devices, where I'm attaching workloads, the bare metals, and where I have virtual routers that are equivalent to virtual TORs, where I'm attaching workloads as well, which could be virtual machine or containers. So my enforcement point, where I'm controlling the forwarding, controlling the overlay topology, controlling the attachment of workloads and collecting analytics, and enforcing high-level semantic policies to low-level construct, becomes all of them. Private cloud tenants with a native, public cloud tenants where I may build a local cluster, where vRouter runs, let's say, as part of the AMI, where the virtual machine is spin up. And then it federates from a single pane of glass with the private cloud controllers eventually. Or data center where I manage those devices with Netconfig PC and advertising route with BGP, typically BGP VPN. And going back to the question you asked at the beginning, what is the foundation? And let's go back to the next slide. Yeah.
Actually, if you could go back real quick, I had one question/comment. So in certain environments, so in the middle there, you have the IP WAN internet, right? And then VPN on top of that. And I think it's important to call out that that's something that's very frequently just sort of hand waved over as a thing that, oh yeah, that's just there, right? But in certain environments, you've got you may control the end-to-end from, your in-house stuff all the way up through the wide area networking. Like you may have, an optical network that you run that you have control over everything from layer 1 up to layer 3. Yep. And then you're using private cloud resources. So with the history behind Contrail and with what I think you're saying is that middle bubble there of IP WAN internet doesn't necessarily have to have VPN in it. If you control that whole thing, you can also orchestrate your wide area connectivity if you own that from a management perspective.
And again, what we are saying is that let's take even a simpler example, okay, which is very frequent in the industry. Forget about the virtualized tier here. Forget about the top. Mm-hmm. You got 2 data centers with bare metals.
Sure.
How many modes are there to connect them together? I'm sure you've seen tons, right? So you can see now it's very comfortable to say, okay, I've got my own data center in San Francisco and my one in Dallas. Good. How do you connect them together? 55 different options. Right. From people stitching VLANs across a wide area network on a fiber to doing EVPN layer 2 stretch from this boundary to this boundary.
Or even as complicated as running routed IP.
I got an IP service with a prefix 1, prefix 2, and I link those prefixes left to right. Or I got a microwave link which goes all the way, it's a layer 2 connections from this side to this side. Unusual, but it may still happen. So there's a lot of different configurations. So what we are saying is that VPN is an option. The way you have to automate the connectivity across the data center, there's a lot of different options. There's a few normalized options that we see more frequent. For instance, this to this side, we see a lot of IPsec and we see a lot of direct connect, which is VLAN to VLAN with an IP prefix. On these sides, we see a lot of layer 3 DCI, EVPN or IPVPN, where you can effectively do a lot by configuring and linking routes with the standard IPVPN, separate autonomous systems. There's a few emerging cases where you see this part of the same EVPN cloud. So you have a layer 2 stretch from this side to this side and vice versa. Architecture now, as we haven't seen a lot of implementation, but it's something that we can configure and manage as part of the connected fabric across 2 fabric domains.
Right.
So again, it's a networking problem. It's just about a networking, like a fabric is what? A system that forwards a packet with an IP address to another port based on the IP address. That's all the fabric does. And that's all this fabric does. If you think about that, it's prefixes and forwarding of packets, which is something where Juniper has been pretty good at.
Shouldn't be prefixes, it should be flows.
Well, at the end, it's prefixes or addresses. It's not.
Yeah, if you're only thinking in terms of prefixes, you're legacy and you're going to lose. Has to be flows.
I mean, the flows, it is the way you may detect. You don't want to do forwarding based on flows.
Absolutely we do. Absolutely, because you
would
do.
get very tricky in a distributed environment.
It can get very tricky, but guess what runs through your firewalls and your IPSs and your security compliance engines and your database? And what does your user care about? Your user is a flow experience from the server to the client. If you're only manipulating traffic on prefix, you're going to fail to deliver a viable service over time.
Well,
I understand that a scaling problem today is that you can only do destination prefixes, but it's not going to be a long-term solution.
Is that, Greg, though, because it's a state problem, and we're assuming that there's a device in the path that has to maintain state?
Yep. We have
You've got to do one of 2 things. You've
Yep.
either got to watch the flow or you got to fix the state problem.
Yep. And the answer is you can't fix the state limitations today. Because they're using BGP, they can't do more than destination routing.
No, you can. I mean, if you take it to the flow level, you could do BG flow spec. And the industry is saying exactly, flow spec is typically an exception. So you cannot do a wide-scale, inter-cloud scalable solution using flow specs, okay? So the problem you're stating is very valid until it's used not in a complete heterogeneous environment which is widely distributed because of the problems of scale. So I'm not saying that flows is not the right way to go. And as Aniket said, you can go up to the layer 7.
Yep.
Do you want to do layer 7 everywhere on every type of forwarding of flows, or do you want to do that on a specific aspects where it makes sense? Because if you do that even on the wide area network, layer 7 inspection, obviously you've got a scale problem.
Yep. No, I need to do it at source prefix and destination prefix as a viable flow. I can summarize flow data, but I still need to have flow information because that's ultimately what I always end up with at the most complex points.
That's what makes sense to have.
Apply the execution of that at the service edge, right? So
Yeah.
then the core can be dumb.
That's why it makes sense to have a much closer loop between the way you configure and enforce services and the way you collect feedback, okay?
Yep.
Because obviously, what do you want to do? Forward just based on 5 tuple entries, source and destination in each and every point? Think about Tor devices. Tor devices have no clue about flows. No. Zero. So there's no way you can enforce that there. So you need to have a level of control on the forwarding which is based on the collection of analytics information, instead of building the states by 5 tuples in each and every point. I mean, we are seeing in the industry of private clouds and data centers, cost of lease is going down, 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 down. There's merchant silicon everywhere there. And there's just a few devices which are scalable enough to build stateful entries. So what you have to do is really be able to onboard all those type of devices, whether they're large ASIC-based router or very cheap Tor devices, and I'm able to configure and leak routes to them, and I'm able to collect whatever it comes as an analytics. In some cases, even gRPC, it's a nice implementation for analytics, but it's much easier to get as flow from an interface or from a logical interface. So I need to be able to collect all those protocols, whether it's JFlow, SFlow, or gRPC, or SNMP, MIB updates, and collect as inputs into a single analytics engine, and perform the correlations to the underlay and overlay to automate the management of service. And what is a service? The service is the networking between application workloads across those environments, whether they are sitting as virtual workloads. And again, here, vRouter is the virtual Tor layer. Then I got the physical Tor layer, okay, where I'm enforcing. Then I got the spines. Then I got the gateways. They are higher cost devices. So I may collect JFlow from here. I may collect SFlow or gRPC from those devices. I may collect Sandesh, which is a richer version of gRPC, obviously, from these devices. And this is the way I can measure flows. I'm not building flow state on flow state in each and every of those elements. And again, the public cloud is an IP fabric, typically configured between the boundaries, where in the private cloud, the boundary is usually the SDN gateway or the one gateway. And in the public cloud is either the VGW with the API gateway or the Direct Connect IFL, the virtual interface.
So from your standpoint, the fabric is just the transport.
Yeah.
You don't care which of the 51 options I use to manage my transport, and for you, the fabric. Yeah.
What we are seeing is that in the private cloud, we see a trend to normalize, to go away from proprietary options and normalize about 3, 5, 7 stage IP clause because it's scale, because it's proven. So you typically, and a 3, 5 stage or 5, 7 stage IP clause running BGP, VPN, VXLAN as the overlay and BGP, VPN as the control protocol is the way the industry is normalizing for both enterprise and service providers. So while we are very open to all the different options, we see a mainline trend where VPN, VXLAN is the prominent directions for the overlay management. And it applies consistently across those environments. So you typically, in a private cloud, you may have a VTAP, which is an VPN, VXLAN, VTAP terminating here, or terminating here, or terminating here, or terminating any of these layers. In some situations, although it's less scalable, you see that terminating on the compute itself. So you've got an OpenStack compute which may operate as a VTAP terminations for VPN, VXLAN. So this is the way we do see directions from a clause perspective in the fabric. Shifting away from proprietary fabric, focusing on standardized fabric for interoperability, for alignment of control, and even alignment of multi-vendor inside the fabric itself, where this may come from a vendor, this may come from another. Okay?
It would be great if everybody is shifting in the same direction
It's
and we
gonna take
get
some
away
time,
from
okay?
these many islands that we have at the moment.
So it's going to take some time, but that's the prominent direction we're working on. So if you see this from a controller perspective, those guys controlled by this control plane participate in the VPN routing by being a route reflector peer to the spines or to the gateways or to the all components of the fabric itself. So those guys receive VXMPP, but it carries BGP, VPN information, the same routes that are received by these guys. So your overlay is a VXLAN overlay controlled by an VPN VXLAN protocol to those devices and to those devices. So the key idea is really a normalization of the technology. But why is it important? The key important is that in order to manage the overlays on those guys, I need to act on configurations. If these guys have a proprietary configuration, there's going to be 2,000 different flavors. So I'd rather normalize on that, use an IP clause, and do the configuration of overlays, which is what matters to our customers, right? They want to connect apps. They don't care how beautiful or how complicated is the CLI to configure an underlay, if then you cannot interwork between this and this. So what we're really doing is making it simple, a standardized IP clause configuration, so they can really work at application-to-application networking as a service connectivity. And I know I'll not be able to cover all the slides, so there's a lot of details you need to go offline, but any questions? Here's a ton of detail which I'm not going to cover, but so what we're going to do is really onboard the pieces of the fabrics, whether it's the what we call DC fabrics. You onboard the devices, you discover, you configure, brownfield or greenfield. There's still some options, even if you normalize about IP clause and EVP and VXLAN. But you still have the principle of fabric building blocks and service objects. Switches, routers, public cloud tenants, vRouters, they're all fabric building blocks. Service objects are workloads. Typically, we don't manage workloads. The only area where we have to manage workloads is bare metals, because there is no tool to spin up a bare metal other than a person cabling up the bare metal itself. And importing and discovery of cloud tenants, again, compute, networking, storage, to abstract it. In order to do that, the three pillars, build your tenant projects, virtual networks, and how they connect together with policies, which can be from a low level to a higher level semantic policies. Provide visibility and analytics to ensure the SLA of the services from an application to application networking standpoint is up and running.
Can you give some insights on the troubleshooting? Yeah, you are dealing with a lot of infrastructure components here. Yeah, how do you, let's say, combine all these and find, let's say, in a transport problem, what is causing the problem? Yeah.
Typically, you have a top-down approach, and that's the approach you are taking up, right? So instead of doing the troubleshooting in the, we say, old networking way, sometimes troubleshooting is biased by the experience of who troubleshoots, whether it comes from a private cloud data center, whether it comes from an application. The service that networking as a service delivers is from a DC or cloud operation team, which they don't know how the apps talk together. So they know what the networking of those applications they have to deliver, but what those applications do sometimes is outside their responsibility, okay? So if I'm serving with my own multi-cloud infrastructure, my HR department, I don't have the details about that, how the app works. I know that I need to connect those workloads to those workloads, and they may exist in different cloud environments. So what we typically do is a top-down approach, starting from how the apps should go, and then drilling down through analytics or to control information. So understand, for instance, first analytics, is the service connectivity up and running in this environment? Then next level, infrastructure analytics. How does that service use the infrastructure? So you see the overlay, underlay correlation. Third point, the underlay is working, but something is not going right. Is there a problem of forwarding? Is a problem of routing control? And then you get to the route leaking to the different elements and visibility through a single pane of glass on how the forwarding is piloted by the control plane. So you have a gradual level, but it still starts top-down instead of going bottom-up like we used to do in the old CLI times. You've got an EVPN which isn't working, so the first thing you do is go look at the RIP table for EVPN, then you look at the FIB, then you look at the VLAN. So it's really kind of a guess mode. Here, it's driven top-down. Networking that I need to achieve, and you start going steps down, drilling into the element specifically. It changes a bit the paradigm of networking, if you see like that. The first thing you do is taking care about what service you're delivering to the applications, and you go step by step down instead of doing the vice versa from a switch or router perspective.
Sounds great. I think it's the right approach and the right direction you are going in.
I think I'm out of time, so time for a few last questions, comments. Please.
How do you envision this being rolled out in a brownfield environment?
Typically, you bring up, I mean, there's different models, but I would say one case is where you have a DC fabric with your own switches and router which are already up and running and configured. So you just onboard those devices by management address without doing any configuration, and you create a peering from a BGP VPN perspective so that your controller has visibility of the clouds. Consider in this model, you may not even have virtual routers deployed. You just have physical enforcement points, so your controller just sits there and does a BGP peering to learn everything, and gradually start. It doesn't do anything from a day 0, day 1 operations. It starts managing overlay services from that angle.